Scale drawings and scale factor. Here we go. So, before we start anything, let's rediscuss ratios and proportions. Again, a ratio is a comparison of two quantities. Remember when we talked about the ratio of boys to girls? If there are 10 boys and 12 girls in a class, the ratio of boys to girls is 10 to 12. When we're writing ratios, ratios can be written in words, meaning the word to. So if it's 10 boys and 12 girls, it would be 10 to 12. We can write it with a colon. So we would write it as 10 to 12. And we would write it as a fraction. Which would be 10 over 12. Now, remember, a proportion, on the other hand, states that two ratios, or fractions, are equal to each other. Okay, so two ratios that are equal, or two fractions that are equal. So for example, 10 to 12 is equal to 5 to 6. This is an example of a proportion. Okay, that's what that is. It's a proportion. All right, so scale. Scale is a ratio between two sets of measurements. For example, if I'm looking at a drawing and I say that the scale is 1/4 of an inch equals 1 foot, that means that every quarter of an inch on that drawing is equivalent to 1 foot in real life. If I'm looking at a map, you've probably seen a scale on a map, okay? 1 inch equals 250 miles. That means that if I have a map, I might have something that looks like this, and I might have 0 and then 250 miles. And that's basically telling me that if I'm looking at this distance, and if this is an inch, that inch is equal to 250 miles. So if I have two dots that are an inch apart from each other, this whole distance is 250 miles in real life. Scale drawings. So I'm going to read this to you. The scale is shown as the length in the drawing, then a colon, then the matching length on the real thing. For example, the drawing below has a scale of 1 to 10. So anything drawn with a size of 1, clearly I didn't put any units there, would have a size of 10 in the real world. So a measure of 150 millimeters in the drawing would be equal to 1,500 millimeters on the real horse. Okay, so that would be the ratio of the scale in the drawings. Okay, it would be 1 to 10, but we got that 1 to 10 because we did 150 to 1,500. Okay, I can divide both of these out and it would actually give me 1 to 10 because I could divide both by 150. I could think of it as a fraction as well. 150 to 1,500. 150 divided by 150 is 1. 1,500 divided by 150 is 10. Okay? Remember, these mean the same thing. They both mean 1 to 10. Scale model or scale drawing. So scale drawing or model is a drawing that uses a scale to make an object smaller than, which is called a reduction, or larger than, which is called an enlargement, the real object. Okay? So when you use a scale drawing or a scale model, you're either making an object bigger or smaller. Well, let's think about things that would be reductions, right? If we're thinking about a reduction, model car, model airplane, just gonna write plane, model house. What about an enlargement? How about a model of an atom? Or a model of bacteria? Okay, something that's microscopic, that's being enlarged so that you can see it. Scale factor. So scale factor is a ratio used to enlarge or reduce similar figures. Now when you're using scale factor, when I'm using scale factor, remember scale factor is a ratio that you use to make something bigger or smaller. So if I have this box and it's a 2 by 3 box, okay, and I tell you that the ratio from box A to box B is 1 to 2, okay, meaning that the scale factor is 2. Notice that box B is bigger. So if I have a scale factor of 2, this means that I'm going to take each of these sides and multiply them by 2. Well, 2 times 2 is 4, which is right here. And 3 times 2, which is my scale factor, is 6. Which just means that I doubled the dimensions of this box. So, what I want you to remember, okay, is the following when we're dealing with scale factor. You always, okay, no exceptions, you always multiply by the scale factor. I'm going to call scale factor SF, okay? SF means scale factor. You always, always, always multiply by the scale factor. You might be thinking, well, what if I'm doing a reduction? Shouldn't I be dividing? Well, no, you're still multiplying, but instead, it's going to look like this. So if I have a larger box, let's say this is 8 by 10, and I tell you that the scale factor, actually I'm going to ask you what the scale factor is. You're going to figure it out for me. If I want to go from A to B, what am I multiplying by? What am I multiplying my sides in A by to get my sides in B? Well, if I need to figure out 8 times something, so I'm going to call that x equals 4. Remember how we solve this? Divide by 8, divide by 8. You get x equals 1/2. So guess what my scale factor is? That's right. My scale factor is 1/2. because 1/2 times 8 gives me 4, and 10 times 1/2 is 5. Okay? So remember what we talked about when we were talking about transformations. My original, which in this case I'm going to call A because I'm going from A to B, my original figure, this is called the pre-image. And the new box is called the image. What did we figure out? What did we figure out when we did this? Well, we figured out that if we want to make something larger, or do an enlargement, then your scale factor has to be greater than 1. Can it equal 1? No. Because if I have a 2x3 box and I tell you the scale factor is 1, well, remember you multiply the scale factor. 2 times 1 is 2 times 1 stays 2, and 3 times 1 stays 3. Nothing changed. I still have a 2x3 box. So it's neither an enlargement nor reduction. Well, what about a reduction? When I'm making something smaller, what I never ever want you to tell me is that you just multiply by something that's negative, because negative numbers are smaller than positive numbers. So what? Let's think about this. Let's say that you tell me that the scale factor to something is -2. Okay, let's use our 2x3 box. 2 times -2 gives me -4. 3 times -2 gives me -6. Those look legit, right? You show me what -4 inches looks like. You show me what -6 centimeters looks like. -4 miles. -6 feet. What does that look like? Can I walk -6 feet? No. Even if I walk backwards, that distance is only 6 feet. It's positive. All distances are positive. All units of measure are positive. Okay, so if I'm doing a reduction, I can't do this. No negatives. What we did find out though, when we made the last thing smaller, we went from 8 to 4, 10 to 5. Obviously a 4x5 is smaller than an 8x10. What kind of number is this? Oh yeah, it's a fraction. So guess what? If I'm doing a reduction, my scale factor has to be greater than 0, but it has to be less than 1. Okay? 1/2, 1/4, 1/8, 2/3 has to be less than 1 but greater than 0. Please don't ever tell me that just because this is a fraction that it's a reduction. Remember, 3/2 is the same thing as 1.5. 1.5 is definitely greater than 1. So this is actually an enlargement. Just because it's a fraction doesn't mean that you're going to get a reduction. It just means that you need to know whether the fraction is smaller than 1 or greater than 1. Okay? The lengths and the widths of objects of a scale drawing or model are proportional to the lengths and the widths of the actual object. Sounds about right, right? This is basically telling me that if I have a 5x2 box that my lengths are proportional and my widths are proportional by the same ratio. Okay? If I compare these, I have to double 5 to get 10. I have to double 2 to get 4. Okay? So if I call this box A and I call this box B, the ratio of my sides, my length over my width, let's say 5 is my length and 2 is my width for A, and in B, my length over my width is 10 over 4. Notice that 5 halves and 10 fourths or 10 quarters are proportional, because again, this is times 2, this is times 2, so that makes my lengths and my widths of both boxes proportional. And I can go the opposite direction, right? This times 2 is if I went from 5 to 10 or from 2 to 4. But what if I went the opposite direction? What if I wanted to go from 10 to 5 or from 4 to 2? Now instead of times 2, it's times 1/2. So that basically tells me that my scale factor going from A to B is times 2, and my scale factor going from B to A, here my scale factor is 1/2. And let's write this, first off, let's make that a little better. And then let's actually call this scale factor. Hey, that kind of looks like it too. Cool. Okay. So again, the lengths and the widths of objects of a scale drawing or model are proportional to the lengths and widths of the actual object. So going back, if A was the model and B was the actual object, okay, the ratios of their lengths to their widths should be the same, which they are. They're proportional, which means they have to be the same. Even more vocab. So I'm going to read this to you, and then I'm going to explain this to you. Corresponding sides. Corresponding sides refers to a pair of matching sides that are in the same spot in two different shapes. Corresponding angles basically refers to a pair of matching angles that are in the same spot in two different shapes. So, let's go with this. Let's say this is 4, and this is 1. And then in this rectangle, this is 3, and this is 12. I'm going to call this A, B, C, D. And then I'm going to call this E, F, G, H. So when I'm referring to corresponding sides, and actually let me fix this so that this makes even more sense. Let's say this is 5 and this is 2. Let's say this is 15 and this is 6. Okay? So when you refer to a side, you name it by the two vertices. Okay, and a vertex is just a corner. So if I'm looking at the first rectangle, this is a corner at A, this is a corner at B. So if I'm looking at the side that has a 1, I would call this side AB. Now, what do you notice about side AB versus the other sides in the same rectangle? I mean, not rectangle, in the same quadrilateral. I've got A, B, C, D. I've got a side of 1, a side of 2, a side of 4, and a side of 5. What do you notice about side AB? It's the smallest side, right? So because it's the smallest side, and I'm going to label that as smallest, right? Because it's the smallest side, it has to be proportional to its corresponding side in the other quadrilateral, which means basically find the other smallest side. Well, if AB is 1, and that's the smallest side in the first quadrilateral, what's the smallest side in the second one? What's the smallest side in EFGH? It's 3, right? 3 is smaller than 6, 15, and 12. So this is the smallest. So in this case, we would say that AB corresponds to EF, okay? That's telling me that this side right here, AB, corresponds to EF. So if we ever make any sort of proportion, we would be comparing AB and EF in some way, okay? Now, let's keep going. I'm going to keep the green. What about AD? What about, oops, I meant to pick red. What about AD? That's still not red. I think I'm losing my mind. Here we go. AD. What does that correspond to? What is its corresponding side? Well, what do you notice about AD? It's the second largest, right? It's the second biggest side in ABCD. So it's the second biggest. Well, what's the second biggest in EFGH? What's the second biggest in EFGH? It's 12, which is FG. There we go. So AD corresponds to FG. So now I can do this. AD corresponds to FG. I'm going to let you figure out what DC corresponds to, and then what BC corresponds to. So as I'm writing this, figure that out. Hopefully you're taking notes on this. So DC, in this case, is 2. 2 is my second smallest side. So what does it correspond to? Good. It corresponds to GH. Okay. Or HG. I'm going to call it GH. And then finally, BC. BC, which is 5, which is my biggest side, corresponds to 15. which is EH. Okay, so those are corresponding sides. They're the ones that match up and are proportional to each other. Smallest to smallest, biggest to biggest, and everything in between. Okay, second smallest to second smallest, second biggest to second biggest. Okay, you're always comparing corresponding sides when you need to. Well, let's talk about corresponding angles. I'm just going to make a couple of these as my example. What if I'm talking about angle A? What do I notice about angle A? What sides make it up? The smallest side and the second smallest side. Well, luckily I also color coordinated my corresponding sides. So I'm looking for the green and the orange, which means that angle A, I'm going to do this real quick, which means angle A, and that symbol I put before the A means angle, corresponds to, I'm just going to say C2 for corresponds to, which angle? Good. Angle F. Angle F. Because it is also between the smallest and the second largest. Let's just finish this off. What about angle B, angle C, and angle D? What does angle B correspond to, C correspond to, and D correspond to? I'm just going to do arrows now. B corresponds to what? Let's use red. B has the smallest and the largest sides, which is right here. So it's angle E. What about C and D? C corresponds to, I've got the second smallest and the largest. So here's the second smallest and the largest. So angle H. And then finally, angle D corresponds to angle G. Now what can I figure out about corresponding angles? We already know that the sides have to be proportional, which means what? How are the angles in, how are the sides in A related to the sides in B? How would I get from A to B? What is my scale factor? Well, my scale factor to go from 2 to 6, from 1 to 3, from 4 to 12, from 5 to 15, my scale factor, where am I going to put this? All the way to the side. My scale factor is 3. Okay, my scale factor is 3. What if I went from B to A? Now what's my scale factor? If you say divide by 3, what do you actually mean? What are you multiplying by? Good. 1/3. Okay, so those are my scale factors of my sides. What happens to my angles? Let's think about this in terms of triangles, or even in terms of a rectangle. Let's think of it as a rectangle. Let's go back to 2 by 3. Here's, let's say my scale factor going from A to B is 4. So now this is 8 and this is 12. What happens to my angles? If you say they multiply by 4, you're absolutely incorrect. Here's why. What do I know about a rectangle? Its opposite sides are the same. What do I know about its angles? They're all 90 degrees. Yep. So if all of these are 90 degrees for A, and you're telling me that B is still a rectangle, regardless of how much bigger it is than A, what do I know about the angles of any rectangle? They're all 90 degrees. So guess what happens to the angles, to the corresponding angles? Corresponding, it's a really long word, angles are always the same. Sorry, that's how I feel whenever I write exponents. It's like the screaming starts. But that's what happens. They always stay the same. You know what the scale factor does to the angles? The scale factor does nothing. Absolutely nothing. The scale factor has no bearing on the angles, only on the sides and the perimeter and the area, but we're going to get to that later. Okay? As of right now, corresponding angles do not change. They are always the same. Otherwise, when you apply a scale factor, the shapes won't be the same. So it won't be an exact model. Okay? All right. Let's look at this example. Some practice. I want you to really think about this. A set of landscape plans shows a flower bed that is 6.5 inches wide. The scale on the plans is 1 inch equals 4 feet. Okay? So again, I'm looking at this and it says that I'm looking at landscape plans and the flower bed is 6.5 inches wide in the plans. The scale of the plans is 1 inch equals 4 feet. That means every inch on the plans equals 4 feet in real life. So A asks, what is the width of the actual flower bed? And B asks, what is the scale factor? For the sake of this question, we're going to figure out the scale factor going from, well, we'll do both scale factors. We'll go from the landscape plans to the actual landscape, and then from the actual landscape back to the plans. Okay? So let's work on this. So what do we know? We know that in the plans, we have a 6.5 inch wide flower bed. Okay, this is in the plan, so this is a model. This is my model, or my scale drawing. Okay, we know that the scale is 1 inch equals 4 feet. So if we want to know how big the actual flower bed is, we're going to take what? Our 6.5 inch wide model and do what with it? I'm going to give you a little bit more time. You can figure this out, okay? So pause the video, answer A. If you can, answer B. If you need me to go back, I'll go back. Remember, A says, what is the width of the actual flower bed? And B says, what's the scale factor? And I asked you to find both in this case, okay? Landscape plans to the actual flower bed, and then from the flower bed to the plans. Okay? So hopefully you got it, and you figured out that in order to get the actual flower bed, you're going to take your 6.5, multiply it by 4, and that's going to convert us to 26 feet. This is how big the actual flower bed is. Okay, each inch is equivalent to 4 actual feet. So what about the scale factors? What did you end up getting? Did you end up getting 4 or 1/4? I'll guarantee you that most of you did, and that is incorrect. Why is that incorrect? Well, let's think about this. I'm looking at something that's 6.5 inches wide on a plan, and in real life, it's 26 feet. Clearly, this is not the scale. So if you tell me that my scale factor is 4, going from the plans, which I'm going to call A, to B, which is the actual flower bed, then you're telling me that 6.5 quadrupled, 6.5 inches quadrupled gives me 26 feet. Now, is that true? Let's think about that. If I have 6.5 feet, 6.5 inches, that's 6.5 inches. If I double 6.5 inches, I now have 13 what? 13 inches. If I triple that instead, 6.5 inches tripled gives me 19.5 what? Oh, inches. So 6.5 times 4, if my 6.5 is in inches, doesn't give me 26 feet. It only gives me 26 inches. Is that the same thing as the actual flower bed width? No. So what do I have to do here? How do I figure out my scale factor? Well, what's going on? What do you notice? Where's the discrepancy? One's in inches, and the other one's in feet. My units are different. I can't compare something that's in inches to something that's in feet and expect to get a scale factor that's going to work properly unless I do a little bit more math. Because notice what happened here. I quadrupled it just like my scale told me, not my scale factor, my scale. But I ended up with 26 inches. I wanted 26 feet. Can't always get what you want, I get it. But in this case, we're gonna get what we want. So, let's do this. What do I need to do? First thing is, I need to make all my units the same. Is it gonna be easier for me to change 6.5 inches into feet or 26 feet into inches? That choice is yours. I'm gonna choose to change 26 feet into inches. How do I do that? Well, to figure out how many inches there are in 26 feet, I know that there's, what, about, 12 inches in a foot, right? There's 12 inches in 1 foot. So what would I have to do to change 26 feet into inches? I'd have to multiply it by 12. Okay, so I'm going to do 26 times 12. 26 times 12 is 312. I'm going to put the inches down here because I ran out of room. Okay, 312 inches. So now when I'm looking at this, I'm not comparing 6.5 inches to 26 feet, I'm now comparing 6.5 inches to 312 inches. Okay, does that make sense? If I do the math on that, 6.5 actually does go into 312 evenly. And this now becomes 1 to 48. So I just found one of my scale factors. Guess what I have to do to get the other scale factor? I just get the reciprocal. What's the reciprocal of 1 over 48? It's 48. Okay, it's 48. So my scale factor is either 48 if I want to get bigger going from A to B, or it's 1 over 48 if I want to get smaller going from B to A. Okay, so this ends up being my answer, 48 or 1 over 48. Again, it's because we needed to change my units into the same thing. I can't go from inches to feet. I had to change them all to inches or all to feet to get my scale factor. So try this next one. It says the central chamber of the Lincoln Memorial, which features a marble statue of Abe Lincoln, has a height of 60 feet. So the actual statue is 60 feet. This dude was tall, huh? Suppose a scale model of the chamber has a height of 4 inches. What is the scale of the model? It says write a ratio of the height of the model to the actual height of the statue. I don't know why there's a question mark at the end. Don't judge me. I teach math, not English. Again, write a ratio of the height of the model to the actual height of the statue. And then B's asking, what is the scale factor? Let's see if we can get it this time. So pause the video and we'll go over this after you're done. All right, so what do we know? We know that the statue has a height that's equal to 60 feet. We know the model has a height that's equal to 4 inches. So when it says, let's look at that question again, to write a ratio of the height of the model. So ratio of the height of the model to the height of the statue. Well, then we're going to do 4 inches over 60 feet, which you could also say is 1 inch over 15 feet. And if you really, really, really wanted to, you could write it so that your ratio is completely in inches, and you could even change this, but then you'd have to put it in the same units, okay? And actually write out the units of 1 inch over 180 inches. Now, what would I prefer if I'm just doing a ratio of scales? Doesn't matter, as long as you actually tell me that we're dealing with inches and feet. Now, the scale factor, however, needs to be very, very specific. So we're going to do both scale factors this time. In order to do so, again, we need to do a conversion. So we know 60 feet. We're going to turn that into inches. Well, 6 times 12 is 72, and I'm just going to add a 0. So 60 feet is equal to 720 inches. Okay, 60 feet is equal to 720 inches. So if I want to figure out my scale factor, I'm going to make a ratio of 720 inches, which is the statue's height, to the 4 inches of the model. So let's do that. So we've got 720 over 4, and they're both in inches. 4 goes into 7 once, 4 goes into 32 8 times, and into 0 0 times. So my scale factor is either 180 if I'm making an enlargement going from the model to the statue, or if I'm going from the statue to the model, it's 1 over 180. If I specifically ask you on a test or a quiz to go from the statue to the model, then you need to give me the correct scale factor, not both, the correct one. If I tell you to go from the model to the statue, then you have to tell me the other one. Okay? You should know which one's an enlargement and which one is a reduction. Scale factor of 180 is an enlargement, and a scale factor of 1 over 180 is a reduction. Okay? So that should be pretty evident. Now, if you have any questions on that, it's okay. You can always ask.